Well, I'm going to start us off here a little bit. We're doing a little bit of a chat with our friends. We have come to us Northerners have come to have some deep friendships down in New Orleans and up and down the river, and what we consider to be one river thinking. And over the last 5-6 years, we have various folks, teachers, coming up from New Orleans for the Summer Institute and going to Itasca, the headwaters. And then we have brought down groups of folks from Minnesota. And part of this, the Waters of the Sea Stories, is built from that. So we at Hamline University, welcome to our project, the Center for Global Environmental Education. We're thrilled to engage in what I like to call one river thinking, which is about science, it's about watersheds, but it's also about the cultural and people and friendships that cut across these long distances of half a continent, you might say. So we are thrilled tonight to do our fourth in a series of One River Thinking components. We're calling it Waters of the Sea Stories. And tonight we're going to be looking at the Mississippi River Delta ecology issues and solutions. So we're blessed to have Blaise Pezold with us. He will be presenting. We have just wrapped up a great virtual Mississippi River Delta Institute. We're looking at doing another institute this summer. We'll keep people posted on that on both well, certainly on Minnesota and other places. And we are just rolling out a brand new program called the Dynamic Delta Online, a collaboration with funded with a significant funding from the Meraux Foundation, the Brown Foundation, the National Park Service, folks from Loyola and UNO. A collaborative team have worked together to tell some stories about the Delta. I was talking to one of my colleagues, the grant officer. He says, "Why do you guys care about the Delta so much? Why are you writing this?" And I thought, well, why don't you care? And then I realized he probably didn't know anything about what was going on in the Delta, and that it's a national story. Mississippi is a national resource and river, and we're so thrilled that we're able to educate and engage folks. And many folks tonight are teachers. We're thrilled to be engaged, working with teachers so they can engage in their classrooms. Let's see, a couple components. We are the Center for Global Environmental Education at Hamline University. My name is Tracy Ferdinand. I'm the director of this. We are celebrating our 30th year, and our mission is to foster environmental literacy and stewardship in citizens of all ages. So with that in mind, we're going to officially get started with this program. We're going to use the chat for asking questions. We will be able to take questions after the presentations. John, Shepard, well, actually, I'll get into that in a second. Suggest you keep your mic on mute. Good Zoom hygiene to keep things going well. You may turn on your video if you like. You don't need to have your video on. It really is up to you. And this webinar will be recorded, and we will link to it so you can catch anything that you have missed. So with that,
hey, Tracy.
Yes. Chris.
I put a map for the I put a map for the crew of house floats in the chat.
Excellent.
And if you zoom in on Minneapolis, you guys have 3 participating. You got 681 Sumner Street.
Okay.
You got 1014 Linwood Avenue and 828 Mound Street in St. Paul that are part of the crew of house floats. So thank you.
Excellent. So with as we move forward, we have a framework on how we've approached this. We will start out with John Shepard walking us through some of the visualizations. We've been able to create visualizations that bring to life how certain things work, how science works, how the invisible can be made visible. Jacqueline Richard is with us. She helped visualize the deep ecology of the Mississippi River. We talked about that last time. And John Shepard will be walking us through that tool that you can use. And we have it in kind of multiple forms that you will be able to access it. That will be a part of it. And then Blaise will be talking tonight. He is a coastal and environmental program manager with the Meraux Foundation and been a dear friend of ours. I think he's been up for every Mississippi River up here and institute up here. And every time he came, people wanted to hear more about his stories and his work in the Delta. So that's what we're going to get to learn a bit more tonight. So without further ado, I'll turn it over to John Shepard, and he will walk us through the beginning, and we'll be able to take questions, type them into the chat. We will make sure we get to ask them as we are, after his presentation, we'll take a few, and then after Blaise's, we'll take more. Thank you.
Okay, everybody. Well, welcome. Thanks so much, Tracy, for the introduction. I'm going to spend just a few minutes with you introducing this brand new program that we have created that we are calling Dynamic Delta Online. And you can see we're looking at the main menu screen right now. So at the bottom of the screen, you've got a barge pushing, or a tugboat pushing 3 barges, and there are 9 containers on those barges. Those are the modules that are in the program. So you get an idea of what the content looks like. I'll just say a little bit about each of them. Crime scene, welcome aboard, just kind of is a number of elements that welcome you to the Delta region and to this program. Crime scene looks at non-point source pollution and its impacts on the river and solutions to that. The Delta through time is the geologic history element that is fascinating. That's the piece we developed with Jacqueline Richard and others. River birds is all about birds that use the Mississippi as a flyway. Otters and ecosystems introduces basic ecosystem functions and takes a closer look at otters as a species. Riverboats and navigation is all about how important the river is and the Delta is for navigation for commercial shipping. And then wetland adventure is where we're going to take a little closer look. So I'll click on that. This is what that module looks like. Every module is designed in the same way. So we have 3 videos, or in this case, there's an interactive element in the middle here on the left. And then we have an interactive element in the kind of the larger part of the screen, and then supportive activities down below. So word search puzzles, a complimentary reading, a quiz, and then we have a wealth of Go Deeper resources in our Waters to the Sea program. This entire Dynamic Delta is really targeted for grades 4 through 6, although you'll find content that could be used in other grade levels as well. So I'm going to show you just a couple of things quickly. The exploring wetlands, this is our ecosystem module. So you'll see links at the bottom of the screen here. This is all about cradles of life, exploring Delta ecosystems. Each of the links at the bottom of the screen introduces you to a different ecosystem found within the Delta. And the Gulf of Mexico is over to the right, so this is a kind of a cross section. The upper part of the Delta is here. We have forested wetlands, ridges. There are 4 types of marshes. We look at open water estuaries and barrier islands. So each one of these, when you click one of these, there's a wealth of content, maps, 360 videos, panoramas of special environments, image galleries. So lots of content that you can explore. And maybe Cora or somebody, if you could put the link to this Dynamic Delta program in the chat, just so folks can get an access to that. That would be great. And then before I turn things over to Blaise for his main presentation, I'm going to play this introductory video. This is a video that was produced by the Cornell Lab of Ornithology. It's about 5 minutes long, and it does an incredible job with just vivid imagery of giving you a sense of the incredible biological richness of the Delta. It also introduces the different ecosystems, and it's a great starting point for the presentation that Blaise will be giving for us. So I'm going to play this, and then we'll go on from there.
The Mississippi Delta is one of the richest wetland communities on planet Earth, fed by a half a continent's worth of nutrients that are coming down the river and then spread out there across these different habitats. The total biomass, just the amount of living organism that is in there in the water, is beyond imagination. You can see that because some of these breeding colonies of birds have thousands and thousands of breeding pairs That huge community is telling us that the delta itself, the marsh systems out there, are teeming with life.
Louisiana has over 2 million acres of marsh, and that's probably 40% or so of the United States marshes.
It's huge. It's extensive. I mean, this is not along the Atlantic coast in New England where you've got a small little patch of a marsh. These are very extensive areas that you can see for miles.
What looks like just marsh to the untrained eye is actually entirely separate ecosystems that interact and that support a tremendous amount of life.
This is a system that stretches from the southern part of the Mississippi River out through these beautiful cypress forests, through these freshwater marshes, through these brackish marshes, out into the bays, ultimately culminating in the barrier islands and in the rich diversity of life that lives out there at the sea.
It's just a very rich, productive system that supports up to 40% of the nation's waterfowl during the winter and supports 40% or so of the nation's raptors, shorebirds, and waterfowl during migration.
As you go down through the delta, you start from one of the most iconic American habitats that there is, the cypress swamp forests of the South. Wading birds, various species of herons and ibises, love to roost in these trees. Those wading birds will spend the day dispersing out into the surrounding swamps, feeding on fish and frogs and so on, and then coming back together and living overnight in a squawking madhouse on the tops of these trees. Just downstream, so to speak, from the cypress forest, but still in that freshwater environment of the upper delta, you get freshwater marshes. The deeper water areas of the freshwater marshes out there, of course, are enormously important as wintering grounds for North America's duck populations.
Most of the nation's ducks end up down here at some point during their life cycle.
There is a huge community of ardent conservationists who believe in the protection and enhancement of wetland areas, specifically because they supply us recreation and food in the form of hunting. A lot of the big rookeries of wading birds along the Mississippi Delta are right there at that interface between fresh and salt water. When you get farther down into the pure saltwater marshes, these are the places that looks like just nothing but grass, but actually are enormously diverse in terms of their invertebrate fauna, which we use as a rich fishing industry and a shrimping industry, but which those birds, they're going out there and feeding on every one of those different size classes of organisms. Ultimately, all of those are fed by the huge fertility and productivity of the marsh systems that are right there at the interface between the delta and the sea.
The barrier islands during the breeding season are just packed with birds. Tremendous numbers of brown pelicans, black skimmers, many of the terns, royal tern, sandwich tern.
These birds out there in the barrier islands tell us that there is a comparably huge diversity of organic life in those habitats that we can't see for the most part, except just by a hair as it goes down the gullet of a bird. This really is a region of the United States that is unique on the planet in its diversity, in its importance, both to the natural systems out there and to the humans that live in the region.
Okay, well, thank you for joining us and watching that. When I see that, I'm astonished at the richness of life there in the Delta and the importance of that environment. And it's facing lots of challenges, which our good friend Blaise will now tell us about, and some of the efforts being made to address those issues. So I'm going to stop sharing, and Blaise, happy to turn things over to you.
Y'all give me a second. I'm having some technical difficulties.
While you're getting ready to go there, I'll just add to really encourage those of you who are teachers and anybody else interested, please make use of these educational resources, the Dynamic Delta or Waters to the Sea programs. And, you don't have to be a teacher, but they're there, they're free, and love to have you make use of them. So go ahead, Blaise.
All right, guys. My name is Blaise Pezold. I'm the Coastal and Environmental Program Manager for the Meraux Foundation. And I'm not a teacher at all, but I'm asked to teach teachers once a year for MRDI. And it's kind of an awkward position for me because I don't really, like I said, I'm not a teacher at all. I actually just build coastal projects. But I'll give it my best as far as explaining everything to y'all. If you have questions, please put them in the chat box, and I'll answer them at the end of this. So Louisiana Coastal Land Loss and Restoration Approaches, all of the tools in the toolbox. I titled it that because I really do believe you have to have multiple solutions on the table in discussion, and you have to attempt multiple or to fix things multiple different ways. So we have the Mississippi River. I don't remember how many states it drains. It drains a lot. It drains into Canada and up here into Montana. And there's 6 major basins. There's Missouri, the upper Mississippi, where I think a lot of the people on this live currently. There's the Ohio River Basin that gives us the majority of the water that comes down the Mississippi River. The Missouri is the majority of the sediment. And then the Arkansas White and the Red River, they all feed into the lower Mississippi River Basin here. And normally when people talk about the Delta, they talk about the Mississippi Delta, the Delta Blues. That would be in this area. What we're talking about today is down here. This is the Louisiana Delta, or the Mississippi River Delta, but the Louisiana end. So in order to understand what I was pointing to in the Louisiana Delta, we need to go through some models of what is the underlying geology that created the delta that we're on. So this is a prograding deltaic headland right here. You see it's fresh marsh. This is the Mississippi River and distributary channels, or it's an example of a river, but if you're thinking of it as the Mississippi River, this would be the main channel, and then all these distributary channels. So in the previous slide, you had all of those basins feeding in. Those are tributaries. These are distributaries, and that comes from basically the water slowing down, and when it slows down, then it tries to find the lowest elevation, and because of that, you get these distributary channels. And then so this is a delta building, and when it stops building, you have this situation here, which is an erosional headland. And this is this would be Wax Lake or the Atchafalaya or the end of the Mississippi River. This would be something closer to the end of Bayou Lafourche, or Bayou Terrebonne, in that kind of area of Terrebonne Parish. And what this is the river has now decided it's going to a different spot, and everything has started to slow down here. You start to have brackish marshes and saltwater marshes come in. You have formation of oyster reefs here, and this area that was prograding in this slide, it's now being eroded, and what is eroding it is the waves that crash along the shore here and the angle at which the wind blows them, and that's called longshore transport. Longshore transport, the best way to describe it is, you know, when you're at the beach and you get on a floaty and you're hanging out, and 15 minutes later you realize you're 20 feet down shore. That's longshore transport pushing you down along the shoreline. And the same thing happens for grains of sand. This is where your sand would be deposited, where the main part of the Mississippi River would be at. And as this gets pushed out here, it creates a barrier island off of this erosional headland. Let's fast forward, and this is in thousands of years, guys. That's something I really need to point out. This is geological time. So we now see that this headland has detached from the barrier island. You have more robust oyster reefs as this becomes saltier in here. This would probably be about 16 parts per thousand. And you can see this is all salt marsh at this point. There is no fresh marsh like in this upper spot. And the barrier island is detached. This is very similar to St. Bernard Parish in the eastern end of it in the Biloxi Marsh, and this would be the Chandeleur Islands. And what's interesting about this, and it doesn't show this in the model, but it basically your barrier islands, they start to roll back from storms, and then they get pushed out farther and wider along here from longshore transport, and eventually you end up with what's called a shoal, which is an underwater barrier island. And then this could be depending on the age of the delta, this could be way offshore, but still on the continental shelf of the U.S. And then you can also see these shell reefs are kind of remnants of what was there at one point. So I was talking about the river changing course and forming new headlands, and you know this is a Fisk map from 1944. You can see how the river changes course every couple of years. And in each one of these, it's almost like a garden hose that has too much pressure. You know, it whips back and forth, kind of like a snake. And you had the same thing happen down here in the Delta, where at one point this was the Teche Delta Complex or Maringouin, and then eventually it shifted over here to St. Bernard and Orleans. Then it's shifted down here to the Lafourche Delta, and then most recently it was here in the Plaquemines, and then now we're seeing it form down here in the Atchafalaya. And all of these could be active at one point or another at the same time, but what we've done on the Mississippi River is put up river levees along the Mississippi here to where it does not flood from somewhere south of Cairo, Illinois. And so we have all these levees here that restrain the river from going where it wants to. And we put about 2/3 of the river water comes out of this end. The other third comes out down here. This area doesn't get much fresh water, and then this area doesn't get much fresh water comparative to this and this. And even this in here doesn't have enough fresh water. But another thing to point out is that our coastline, unlike up here, is actually a composite of these different deltaic headlands that came down and switched and went in and out. This is looking at that Bird's Foot Delta that I was pointing out in Plaquemines Parish at the end of where the river comes out. This is where the 2/3 goes out this way. This is the town of Buras. And I like this photo mainly because it shows a bunch of the situations that we face throughout the Louisiana Delta here. The first part is right along here, you have the Mississippi River levee, And then you can see right here, you see this, there's this green kind of zone there. You see, this is another levee coming across here. There's a little bit of marsh here. You have some oil and gas canals. These are straight lines. Anytime you see straight lines in a delta like this, these are oil and gas. But or sometimes shipping.
Hey Blaise,
Yes.
I'm sorry to interrupt. If you're going to use your pointer a lot, do you mind clicking the pointer on the little screen that comes up when you hover and changing it to bigger or a different color?
Got it. Does that work?
Thank you.
All right. So I was saying there's the Mississippi River levee here, and then you can see the back levee for the hurricanes across here. And you see how this town is set up just on the very small sliver along the river. And that's because of the way deltas form geologically. So you have your basic river here, then you have a flood situation. And when we're in a flood situation, you have a whole lot of particles of different types of sediment, and your sand is going to fall out here first, and then as you go farther out, it's going to get finer and finer and start to become more organic in nature. And so after a flood situation or multiple floods, you've had this bank here on the river or a bayou, and that's where we build at. That's this high ground here. But what's interesting about this photo, this east side of the river does not have a levee system that works anymore. The water is able to flow over what was there at one point, and you see all these alluvial patterns, much like those kind of deltaic complexes forming here. And you can see you have this large canal that comes right down through it, and the marsh here doesn't look very broken up. It looks very natural. And this side actually is higher than this side here. That's because this sediment is steadily building just like this right here. And on this west side where we have our levees, it does not build at all. This is actually subsiding because it's inside the levees, because we drain it off and we pump the water out into the wetlands here, and that compacts our soil and subsides it. The other thing to point out, I said this looks like a very healthy wetland here, even though there's an oil and gas canal. These canals essentially opened up the amount of water that can come in and out of here from the Gulf and destroyed this marsh in here. We'll get to that in a later slide, but I just wanted to point out, the river is basically healing this side and doing what rivers do, which is flood. And then this side, it's not allowed to. So if that last slide probably seemed a little bit complex. It's a lot more complex than that. There's so many different interactions. It's really hard to kind of sum them up. And this is kind of a 2D model trying to sum up some of those interactions. Salinity and depth of water usually are the two biggest things that I look at, but presence of oysters, presence of a marsh on the back of a barrier island, what birds are doing, because birds ecologically, they could be dropping excrement anywhere in this situation and seeding things. But I guess the biggest point on this slide is that it's a super complex system, and it's really hard to kind of sum up in a nice little package. But this is probably the closest thing I've seen to where they were trying to explain it all. But I don't think it does it justice as far as the different factors that you have to deal with when designing a coastal project. So these are those deltas that we were talking about, and all of the red on here, that's what we've lost so far. We have two spots right here at that southwestern area where we have 2/3 of the river coming out of here. And then over here where we're actually gaining land, there is a little bit of land gain here, and then there's some here, but this part is a little bit misleading. This is actually those barrier islands rolling over and disappearing from one side and retreating on the other right there. But where you have a riverine influence, you have building land currently. So this map is from 1932 to 2010. So that's a 11-year-old map. We probably lost a little bit more. I don't really have any kind of figures for that as far as what we're currently at. After the last time I gave this PowerPoint, we had a little bit of a discussion, and I think Jackie asked CPRA, and they said they weren't really sure where we're at currently. But you can see
What's
down here.
CPRA?
Oh, thanks, Chris. CPRA is the Coastal Protection and Restoration Agency for the state of Louisiana. They handle all the coastal projects along our shoreline, anything from over here in Texas all the way up to the Mississippi line. And I want to say, money-wise, they're the largest agency in the state at this point. And a lot of that is due to they have a very large budget because of the BP oil spill funds. So how did that happen? How did we get all the red on the map there? Like I said earlier, the river levees, this is at flood stage on the river. You can see all the sediment coming out down here, and then over here in the Atchafalaya, in Atchafalaya Bay, and excuse me. So this levee system channels everything out that way, and then there's a third that we let come out down this way. The other causes of coastal land loss, we had the Mr. Go channel here. We have multiple channels like that in Louisiana that are shortcuts to ports. We have one down here. We have one that goes into Jefferson. There's ones farther over in Lake Charles. Basically, they're shortcuts for shipping to get into city centers, and they drive commerce. But this one actually proved to never really be any kind of economic help for our region, and they have actually defunded it and closed it off right here, and that's a huge deal. I've heard from scientists I respect a whole lot. He said it was, I think, a $9 million project, and the amount of restoration it caused within this entire area. This is called the Pontchartrain Basin. We have not built a project that is equivalent to what that closure did on the Mr. Go. We have oil and gas exploration canals. I kind of touched on those when we were looking at the town of Buras and the two sides of the river. They basically cut across wherever they wanted through our wetlands, and sometimes went right over each other or right next to each other because somebody else owned one spot of land and the other person owned the other side of it. But where you do see where they had a lot of extraction, like say down here in Golden Meadow, there's some areas out here near Comfort Island, and then down here in Plaquemine, you see total collapse of the marsh. We also did a lot of shell mining of natural oyster reefs that were existent along our coast, and we spread out those reefs and turn them into something like very similar to farming, but on the bottom of these bays in here. So it's for the seafood industry. You also have boat wakes. A lot of people refer to Louisiana coast as a working coast. You have tons of offshore oil and gas rigs. You have oyster fishermen, you have shrimpers, you have crabbers, and then you have the guys, the yahoos that come out on the weekends, and all of them are going up and down the bayous and the canals in here and back and forth, and those wakes that they push erode the bank lines. And this is a good example of that. This is on Bayou La Loutre, which is this area right here. And you can see the exposed roots on the land there. We also have natural subsidence. You know, when you add a whole lot of sediment to an area, that sediment will eventually compact and subside. So you do have natural subsidence, but there was also a lot of subsidence caused by oil and gas. And then the last thing is nutria. They are a giant rodent. Think of a beaver with a rat tail. And they brought them in from South America. And they've kind of wreaked havoc along our coastline, so much so that the state government will pay you around $10 a tail for shooting them. And this is I forgot to talk about this. This is oil and gas extraction in Louisiana, and then rapid wetland loss associated with it. I don't remember whose paper that is, but it does not matter. So solutions, the state of Louisiana, every 5 years puts out a new coastal master plan. I think we're on our 4th or 5th iteration of it. And this is it. It's super complex. It costs about $50 billion, and they keep it at that $50 billion number. And new ideas are added every 5 years. But for the most part, it stays very similar to this, but things are often tweaked. So I'll go through a couple things. You have ridge restoration. That's the old channels of the river. Basically dredging out the bayou and piling that sediment up onto the ridge. You have these green polygons. These are marsh creation. The pinkish purple one, those are levees. And some of these levees have already been built. And then you have barrier islands down here. A lot of these have been redone. I think there's like maybe 1 or 2 that have not. And notice they leave the Chandeleur Islands off of that. That's a source of contention down here in St. Bernard. You have different projects based on hydrological restoration and keeping salinities low in areas. You have non-structural programs, these hashed areas that are kind of pinkish purple. The state is really still kind of formulating what their definition of non-structural is, but a good way to explain it is raising houses, buying people out of areas that flood often, probably going to have things like storm shutters and generators and those things built into non-structural. And all of this is designed to try to lower the cost of, impacts upon us based on our coastline and storm surge. And what else? Oh, I didn't point out sediment diversions. You can see all these white blobs coming down here, and all these kind of brownish hashed areas. Those are thought that they're going to be affected by the new diversions coming in, and I'll get to those later on. So I just wanted to go into a couple of types of the techniques that we use along the coastline. The first one I'm looking at is Barrier Island restoration. This is Schofield Island in southern Plaquemine. So this is directly, if you're following on a map at home, this is directly west of Buras. And you can see this is from 2012, before they redid the island. You have a lot of cuts in here, possibly due to hurricanes. You have very little marsh in the back end of it and very little beach here. And it looks, from this, like it gets overtopped often. And when barrier islands get overtopped and when they're not very wide, they're more likely to start rolling back and retreating. And that's not a good thing, because then, you're retreating and then it's also turning into a shoal at the same time, or evolving into a shoal. So, and a good thing to point out, especially for the folks here in Louisiana, you have to have some sort of barrier island formation already there in order to build a barrier island project on it. That's a very important thing to note. You can't just go build a barrier island in the middle of a bay with 15 to 20 feet of water. That's not cost effective. So on the right here is where they rebuilt it. They put about 300 feet of beachfront on here, 300 width. And then they'll put an 8-foot dune along this backside of the beach. They put a couple rows of bitter panicum, a native grass here on the front and the back, and then they put sea oats along the top of that. And they also have what we call a sand fence, which in Minnesota, that would be a snow fence. And the idea with that and the vegetation is to slow, you know, in wintertime, this island might receive wind coming from here from the north, and in the summer it might come from the south, but usually it's northwest and southeast hitting the beach. And that there's a process called saltation where grains of sand basically jump, and then often they hit other grains of sand, mobilizing those. And this is, you know, in a windy situation, and that sand will go and start to move back this way, and then at other times of the year as it's moving back that way. Those sand fences, just like with your snow up north, it keeps it in one spot and from like running across out the beach or into the back marsh. And then, so this is a marsh platform that they built. They have a containment dike around here and there, and then they go pump in mud on there. And this is a very interesting project because previously, most of these barrier island projects, they would take a shoal from offshore here and they would go and pump that shoal onto a beach or a spot that's right near it, maybe at the end of this is called a spit here. At the end of a spit, you have a large body of sand. They would go and try to pump that on. This one, they took it from the river and then went and put it onto the beach. And then they took mud, or I say mud, they took their silt and clay here and created this marsh area. And for this, they don't even have to vegetate it because they're pumping from the river. It's fresh. And the plants that are here eventually just went and took over this whole area. And some other things to point out on this, after they're done with the project, they have this, you know, this berm or dike system that they put up. They have to go and knock holes in it so that it reconnects with the tidal flow, and that this marsh will actually interact with the bay, and the tide will go in and out here. And that also becomes a rookery for different types of fish. So they have this giant pipe and it's coming in from the Mississippi River, right? And here it is down in this bottom picture. And the slurry, which is sediment and water, will come out on one end. And this is a bulldozer, and they'll go and kind of push this out and widen it. And then they'll go and they'll set up more pipe and attach it to another one. And then they go and push it out and push it out. And then they just keep going back and forth and working this island out. So another type of restoration is oyster reefs or artificial oyster reefs. And this is a historical map, obviously. And this is St. Bernard Parish down here. This is Plaquemine, Lafourche down here, and Jefferson there. But you can see on this, the red here was a hot spot historically for oyster reefs. And like I was saying, currently this is a hot spot for growing oysters. And when you, like I was saying earlier, when they laid those oyster reefs down and created, they used old shells as culch. And so when they laid the culch on the bottom of these bays in order to farm it, it destroyed the actual structure out here that was protecting these islands. And so this is a project that I developed with the parish coastal team here. And it plays off of projects that were done previously. So there was a project down here that's done by CRCL, and that was from their oyster recycling program. And then you have this Nature Conservancy project over here that was done through the stimulus under Obama. And then this here, this was a CPRA project done recently, and this tested 4 different types of oyster reefs against each other in one spot. Because before that, it was always, you know, they had them in different spots, and then some were way over here on the coastline, or they weren't comparable. But this is very comparable, and they found that they liked 2 or 3 of the designs, and then 2 weren't as good as they thought they were. And so they now have this extension that they're putting in, I think within the next year or 2. That's called PO 174 in Bay Elwha. And so you can see that this kind of pinkish purple down here. And my thought was like, why don't we extend this all the way up and around for everywhere we can grow oysters? And I tried to break that down into, you know, the state is going to do this. Who can I get to pick up this part? And I'm going to focus on doing this right here. And well, our foundation reached out to Nunez Community College and their welding program, and we have a project permitted for the north side of Comfort Island here. And then, you know, drawing lines on a map, it's kind of crazy, kind of like Field of Dreams. If you build it, they will come, and they did last year for, we have a program called QIPRA down here that's a federal program to rebuild our coastline. And I got a call from a gentleman at NOAA, and he started asking me questions about the Rawhead increment and the Turtle Pen Island increment, which are, I want to say these, the green and the blue there. And he proposed this section of the reef on there. So it was just kind of a cool thing that ended up happening from that. And I'm hoping that eventually we end up building something similar to this so that we can kind of slow the degradation that's going on out here in the Biloxi Marsh. Because ultimately this marsh is the right flank of New Orleans, which would be, well, you can see it here. This is that marsh area that we're looking at. There it is again. And here's New Orleans. And, you know, hurricanes, they rotate counterclockwise. And so the majority of our storm surge comes up in here. So I think it's really important to have this. And it also protects Mississippi as well to the north. So here's the state program on the right that put those different types. These are called reef balls. That's out of a nonprofit in Florida. And then these, that we call them donuts, or the official name is Oystercrete, and they look kind of like donuts or tires out there, but they're made out of concrete. But you can see the oysters adhering to the concrete structures. These are very popular as far as recruitment of oysters. But I think there's some fine tuning that has to be done as far as how close it needs to be to a marsh. And they're actually studying, you know, does the marsh start to grow out to meet the reef? Do they see a net loss here in erosion, or do they at least see us break even when we put in a project like this? Those are the kind of things that they're trying to answer. And then on your left here, this is how oysters naturally kind of end up building a reef in an ecosystem. This is very early on in that kind of stage. But I think this is a very promising technology as far as what we can do. And I think it'll get cheaper as we start to build bigger and bigger projects. Okay, so another restoration approach, we kind of covered that in Barrier Islands, is marsh creation. This is a project I proposed about 2016, so 5 years ago. They finally got done. I do the initial design on these projects, and then they have to do the real engineering and design on it after it gets approved. This one got approved. So this is about 300 acres of marsh back here. some kind of interesting things to note. There was a little bit of a ridge here, and you can see one there, and then you can see the very robust Le Loutre ridge. Basically, all we're going to do is come across here with a berm to create this dredge site. So there's a large amount of cost savings from this U shape right here that we built into the project. And then the idea with this is right along that Mr. Go Canal that I talked about earlier. And these were some low spots in it. This is a high spot. If you go this way, it's high. And if you go here to the right beyond Baker Canal, it's also a high spot. So we're just filling in this low spot. And again, that's this is a ridge project. So you would dredge from the bayou here and to just pile it up on the side of here. And they do that to about 5 feet in height. And then they go and plant it with live oak and hackberry forest. Which is a very important thing to note. You know, we were talking about, or we were looking at that video about birds. Live oak hackberry forest. There's actually, this is a nice picture taken by Bill Haynes' son Noah of this area is actually right over here. But this is live oaks, you can see, and then there's hackberry and some other species that that make up a ridge ecosystem. And that ecosystem is extremely important to trans-Gulf migratory birds. They use this as their last stop before they go across the Gulf of Mexico to the Yucatan Peninsula. And it's their first stop when they come back in. And if you look at the cycles of everything, you know, all the berries and nuts that are dropped from this, and a lot of the insect life cycles coincide with those migrants crossing back and forth. So it's extremely important habitat to build. And then this is marsh buggies building a berm in a dredge project like this red polygon up here. So we talked about the Atchafalaya Bay and how we put a third of the water down that through that basin. And this is where the Atchafalaya River comes out. Just to the north of this is Morgan City, Louisiana. And Morgan City was constantly having an issue with flooding. And the Army Corps of Engineers cut this canal through here to relieve flooding. I'm guessing sometime before 1984. And they immediately started to see a new delta build. You already had the Atchafalaya building here. This is man-made here. This is the Army Corps dredging the channel out here and just piling it up on the side. But you can see this natural delta formation, and it, you know, keep in mind, these have been through multiple hurricanes. They've gotten peeled back. This freshwater marsh that is at the top of this deltaic area, that is super susceptible to getting destroyed I say destroyed, getting knocked back from hurricanes, but it comes right back. And so this right here, the Wax Lake outlet, this is the kind of the impetus for our next restoration approach, the sediment diversions. So they built into the master plan multiple sediment diversions. These are the two that are the largest, and these are the first two that are going to get constructed. The first will be the Mid-Barataria diversion. The second is the Mid-Breton, and I want to say Mid-Breton is running about 5 years behind Mid-Barataria. Mid-Barataria is, I think, about to go into the EIS, which is the environmental review of the project and possible impacts. It's the environmental impact statement is what an EIS stands for. But the hope is this giant lake here will end up looking like this. And this is a model that the state did. If you look, you see this kind of U shape here, and you see this lake to the right. The lake is right here. That's called the Pen. And then this U shape is the old Bayou Barataria. I think it's Bayou Barataria. Bayou Barataria Ridge there. But so this giant area here is supposed to be filled in by all the sediment coming out of this diversion. So this is one of those projects that this is one that's never been done. The oyster reef one I was talking about earlier, that's one of the largest in the world. That was never done on that scale, and this will be another record setter. So this is a schematic of how it'll work. You have your large intake here. You have some gates, and then a straight shot canal to get to the bay and start to build. And the whole thing of this, you want to think hydraulic head, like how fast can we get it running through here with sediment to push that sediment as far out as we can as it builds in here. You know, can we get it over here to the pin? Can we get it down here into, you know, Lake Hermitage? So this is actually my favorite type of project to build. Planting projects are my specialty. I guess I could say I'm an expert on it. I build a lot of them. I build a couple a year, but this is the largest one I worked on. So this is Bayou Gentilly. If you're in New Orleans, this is in Bayou Sauvage National Wildlife Refuge. And what we have here is an impounded wetland. These are all levees going across here. There's a gravity drain here that goes into a canal that goes to a pump system that gets pumped out into the intercoastal waterway. So this is, I want to say, over 1,000 acres. And I was brought to this site by U.S. Fish and Wildlife, and they wanted me to come look over here. They originally had a rookery, which is like we were looking at in that video. That's where wetland birds have all their children. So there's a rookery here, and they wanted to reestablish this rookery on the south side of this. They said that it was still going right before Katrina. Katrina overtopped this levee and made this very salty and destroyed the majority of the trees in it, and thus the rookery. So I kind of talked to them about, you know, you're going to need to start replanting trees, but the first thing you have to get a hold of is this is a large, shallow lake. What gets caused, or what happens here is you'll have wind coming down from the north, or it's coming from the southeast, and that shallow lake, the wind will create giant waves, and they'll go and pummel the side of this and keep all this vegetation from being able to colonize out in here. This is super shallow. I mean, it was, I could walk like 300 feet out into it, and it was solid to walk upon, and it was probably no deeper than knee high, 300 feet out. So I would call this site actually a Goldilocks site when I'm looking for my situation where I want to use vegetation to build a marsh, mainly because of how shallow it was. The salinity was negligible. It's a freshwater wetland, so I could put in many more species. Freshwater wetland has if you get out into a saltwater wetland, you might have 5 or 6 dominant species. In a freshwater wetland, you could have over 50. So you have a lot more options when it comes to this. And then the idea that it's gravity drained, I can go and drop the level of the water in here to where I can go farther out. So we started looking at using bulrush in here and doing double rows. We had what was an old bayou that came across here. It was too deep to mess with, and we just went and put in 3 double rows. And you can see this is row 1, 2, and then there's a 3rd row here. But what you can notice from this slide to this one is the marsh growing out to meet those rows. And so my first double row down here, that's 175 feet that we gained. Your second double row is 300. And then the farthest extent this vegetation has grown out is 620 feet. So within a matter of 2 or 3 years, we've had, you know, hundreds of acres come back within this marsh. When you look at, if you just put a marker here of where the shoreline was and where it is now, it's extensive. And, you know, as the years go by, that's going to creep out and eventually set a new marsh edge out here. And there was also a lot of shallow areas up in this area and here, and I really feel we could amend this project to make it much larger. But I just want to kind of show you all some of the strategy, and then also this is one of my most successful projects, and I'm super proud to have been a part of building this. And this was done through QIPRA's LA 39 vegetation project, which actually is crapped out as far as funding. So hopefully QIPRA will go refund this for another 10 years, because I really feel like there's a whole lot of value. This is exponentially cheaper to build something like this than it is to do a dredge project. So if you're looking back at the Bahia La Lutra project I was pointing out, that's 5 miles of ridge and 300 acres of dredge for about $30 million. This is 300 acres of marsh for $300,000. So there's a huge cost savings, and that means a lot, you know, even for folks up in Minnesota, because that's your tax dollars that are going into this. This is a federal program. So, you know, I had that one really rough slide where I went through everything that's destroying our coastline. And I wanted to kind of end with things to celebrate. So like I was saying earlier, we have that Oyster Shoreline project that's the largest in the world. We're leading in those kind of technologies in the world. We're leading in sediment diversions, and then we're also leading here in dredging. So we have the Lake-Borne Increment 1, which is funded by the BP oil spill damages through a program called LATIG. And LATIG, Lake-Borne Increment 1, is the largest habitat restoration dredge project in the world. So not to be confused with the stuff that they do over in the Persian Gulf with those like Palmetto looking islands. Those are, or the airport they built in Hong Kong. Those are dredge projects for human habitation. This is a dredge project for habitat. So we're a world leader in three huge components, I think, or three huge coastal restoration components. I think, you know, as we move forward with like climate change, and you know, there's so many people that live along coastlines in the world. This is a exportable technology that we're really perfecting down here, and it's something to take note of. So questions? Do we have anything in the chat?
Are we learning
box?
from the Dutch, or the Dutch learning from us?
Good question, Chris. The Dutch have said that they're learning from us at this point. I think as far as like the sand motor project, we're probably learning from them on that. But as far as oyster reef restoration and diversions and things like that, they're kind of astounded with what we've been able to put together and what we're doing currently. So they're now sending their people here to kind of capitalize on the situation. Let me check the chat, see if do we have any questions in the chat. Oop, that is not the way to the chat. How do I get this off?
If anybody has a question, you can go ahead and unmute and ask away.
Blaise, Bob Thomas.
Hey, Bob.
Is that project that you were showing in Bayou Sauvage, is that right parallel to tracks? It's that big open marsh area by the tracks?
The tracks are right here. This is the railroad track.
Where, show it again?
Right here at the north end of it. So if you've ever been to the Joe Madeir Marsh, that's
yeah.
right up here. You would come to the dock over about right there where my marker is for Joe Madeir.
Okay.
And a good thing to note, I do have a project I have multiple projects in Joe Madeir. If you go to where the outer levee wall is up here to the north, you can you can park and go up over it, and there's a whole lot of very peculiar vegetation lines coming across this. And then I have a proposal that I sent in that got approved. I want to say it's been implemented, that comes and cuts off a lot of these little channels up in here.
Blaise, we had one question about how long does it take to start to see results after a restoration project?
Which type?
You choose.
I think the dredge projects are super popular because they're kind of instant. It's built. And you usually, if they're not using offshore sediment, they're colonized immediately. The beach ones, I've seen plants colonizing within the year. Same with the regular marsh creation. The oysters on here, that took a while. I want to say 2 or 3 years for the oysters to start forming. But you can look in this picture, you see the grass kind of creeping out here into this mud flat. That took a couple of years too of these oyster reef systems blocking waves here, and you see how flat the water is here. That it took a while for the grass to kind of reach out and send out its rhizomes or runners and colonize. But a vegetation project, I would say you usually kind of know what's going on in about 2 or 3 years for one of those. But sometimes you see instant, like, hey, this is really happy and it took off. Other times you go out there and you're like, a vegetation project can be kind of a crapshoot where you're like, man, I only had 10% survive, but does that 10% start doing this and start sending out rhizomes and colonize the entire area that you were going for? And you never know. They can be more problematic, because if you have a storm come right after, they can wipe it out. You could have nutria hit it hard. You could have the weekend boaters run through it. You never know what's going to happen. Or you could have water hyacinth, an invasive species. They form these giant rafts or mats. You could have them roll over the top of it. It really depends on the project.
Dr. Bob in the chat said Wax Lake outlet was constructed in 41-42, but the new delta didn't become subaerial until 1973. A similar situation happened at Carnarvon with a fresh water diversion that inadvertently transported sediment. Can you speak to the results of these large scale diversions as far as time?
Well, one of the things with the diversion is you have to be patient. I could look at like West Bay. It took a couple years for that to do anything, and they had to actually build islands out in front of it to capture the sediment that was flowing out of it. I've been down to West Bay a lot, and it really, it might take a couple of years for it to start building, but when it does and it hits there's a point where vegetation can start colonizing, and when that happens, it's kind of an explosion of it. But I have a geology degree from UNO, and as a geologist, when I look at diversions versus, a lot of folks down here would tell you like, no, we only want you to dredge. Diversions are dangerous. It's going to flood us out. It's going to do all those things. If you don't have inputs of sediment, and that was something I was kind of hitting on the some of the first couple slides. If you don't have input of sediment like this, you have a dying patient here. It's not I mean, you can do all kind of stuff that is kind of like putting a stint in, but ultimately, you know, grandpa's going to die. That's the nuts and bolts of it. In some of these, you know, like this formation, like this is eventually going to erode and not be there at some point. At some point, these will be, they already are kind of disconnected islands out here, and you're just going to have this left. So, you know, that's why I was pushing to have an oyster reef around this, because it'll slow that down. You know, and you can put in certain areas, you can put dredge projects that'll slow things down, and I think that's all you're looking at is your best case scenarios to slow things down. Whereas a diversion, you're looking at renewing everything. You're looking at new life. And as far as like them taking, you know, time to build, you have to have, like I was saying with the barrier islands, you have to have something there to build upon first. And so, you know, it takes a couple of years for that sediment to stack and stack and stack. For you to actually see it above water. But I think that one of the cool things about having diversions in our system is we're going to get a crash course in how to manage the outfall of them, how to, you know, what is the best way to manage all this, and you know, is it putting up an island across here? Do I start catching sediment here and I can cut off half a lake? Do I put it at 3/4 and I start catching there, catching sediment that's flowing out? I don't think all of that, the science, that we really understand it all the way. So that'll be interesting. I have a project down in there's a place called Bay Denise down here that I'm working with Tulane and the Water Institute and the NRCS, and we're actually looking at how vegetation can trap these sediment flows coming out of a diversion. But we're using this lake that's filling in as an example.
So worst case scenario, you're shortening a dredge bank.
Say it again.
Well, I'm just saying, if you get all this sediment piled up where it's a problem, we can move it a much shorter distance with the.
Absolutely. And you can see, so we have a lot of projects that are planned through QIPRA for down here in Delacroix and going north along Reggio. All of them borrow out of Lake Leary, and they're borrowing sediment coming from the Carnarvon freshwater diversion here. We used to have this square lake called Big Mar here. It eventually filled in, and when it filled in, now they're complaining that Lake Leary is getting too shallow. But that's where we're borrowing sediment from to build these dredge projects in the first place. So if you don't constantly have sediment inputs here, you can't even build your dredge projects that you want to. You run into a point where there's a finite amount of sediment.
All right.
Good job, Blaise. Thank you.
One more question
Thanks.
that we should probably quickly answer, and then we'll kind of wrap this up. But is there a way for students to get involved with plantings? And Blaise, maybe you can talk specifically about anything in the St. Bernard Parish that you're working on.
Absolutely. So I know Chalmette High, they work often with Coalition to Restore Coastal Louisiana. I'm actually wearing their hat today. And then they also work with Pontchartrain Conservancy, which used to be Lake Pontchartrain Basin Foundation. So Chalmette High School works with them. Most of these groups do not take anybody under high school age, but they do take college age students. And then another option, if you're from Minnesota and you're trying to come down with a student group, like high school one, is Common Ground Relief. They're located in the 9th Ward, and they do a ton of vegetation projects out here.
Excellent. Well,
Thanks,
with that,
guys.
I think we'll wrap it up. We've have an excellent presentation. So let's give a round of virtual applause to Blaise. Thank you so much.